Example number 2, we have the function fx equals to 1 over 2 power of 3 minus x plus 1. And as we can see in this function here, the base number of our exponent is less than 1, which doesn't fulfill the form that we want for the first step. So what we need to do now is that let us change the base number here into some number which is greater than 1. So by changing to base number greater than 1, I will have 1 over 2, we return it as 2 to the power of minus 1. And further, we expand the power, we have the result fx equals to 2 power of x minus 3 plus 1. And in this form here that we have changed, it fulfills the formation that we need, where we can see that the capital A equals to 1, which is the coefficient on the exponent term. The m equals to 1, which is the coefficient of x equals to 1. C is minus 3. K is equals to 1, the constant k. Next, once we have changed to this form here, the next thing we want to do is that we want to determine the shape of the graph. So, by referring to fx equals to 2 power of x minus 3 plus 1, we find out that on the power, the coefficient of the x is positive. And we notice that the coefficient of the exponent is positive also. So with positive on x, positive on the function, for the case the base number is greater than 1, again I want to emphasize, for the base number here greater than 1, we don't refer to the original one, but we refer to this one after we change base. We notice that the shape of the graph will look something like this. And once we identify the shape, the next thing what we want to do now is that we would like to go on with the step 3, where we want to determine the special line, which this dotted line here, where we call it as the asymptote. And how we determine this horizontal asymptote here is just that we refer to the constant here and let it y equals to 1. Therefore, this is the horizontal asymptote that we have. And once this step is done, by right at this moment here, I can determine the domain and range. And as you can see, when the time the graph is happen to be extended, we can have the domain, which is infinity to infinity. As we can see, the graph can extend to the left infinitely, extend to the right infinitely. Whereas for the case of range, we want to see how high and how low our graph can go. When the graph is extended, we notice that it can go upwards infinitely, which gives us positive infinity. Then it can go as low as close to this horizontal asymptote but never touch it. So the range will be 1 to infinity. So this is how we can use the first 3 steps here to observe the domain and range by graphical methods. Next, step 4. We would like to identify whether x and y intercept exist or not in our graph sketching here. So with the help of the special line, the horizontal asymptote in this case here, and also the shape that we identified from step 2, we can see from rough sketch, this is what is roughly going on in the graph later, where we observe that there is a y-intercept and there is no intercept at all in this case here. So therefore, the next thing what we're going to do after we observe from the rough sketch here is that we try to calculate the y-intercept. And y-intercept happens when x equal to 0. Substitute x equals 0 into the functions. We get 9 over 8, and 9 over 8 is the y-intercept. And as we see just now, there is no x-intercept, so therefore we don't have to find it because it does not exist. At last, we're able to identify what is the value of this y-intercept combined with all the previous info we have, which is the asymptote and also the graph shape. So this is the result that we have for the graph sketching. And always remember, make sure you do label the xy axis, the origin, state the name of the graph, label the xy intercept if they happen to exist, And also, don't forget the horizontal asymptote. So this is how we sketch the graph for example number 2 here.